Next problem, it's a particle of mass m starts at rest and move a vertical distance in the present of a gravitational field, which is F equals to negative mg(j). Now we're looking for find the work done by the force, which is from the original equation I just gave you, going to y prime, y1 equals to 10 meters, to y2, 6 meters. So for A, we're going to start with this. All right, A here. They originally give us y1 equals to 10m and y2 equals to 6m, right? Yeah. And then they give us that we have velocity initial as well, which is 0. And we also have the equation, which we're looking at, which is negative mg, and mass being m. Okay. So for the first problem, at least, since we just wrote out the variables we know, right? For the first problem for A, right, we can say that we have a vertical distance. We have 1 and 2, and we start at y2 is to be 6m and 10m. Now, this is a distance of 4m, and we can say that since it's moving in a negative direction due to the equation, right, a gravitational field, which is mg, right, we could say that the full body diagram that we're doing is going downwards. Let me write this in a different color. It's going downwards with mg, right? So the work is going to be here. Let me write this out again. So we're going to start with work, which is just equals to F ds, and ds is, ds is equal to 4. And we know that mg times 4 equals w, and we can figure out that, okay, w, it will be greater than 0, so kinetic energy will be greater than 0, okay? So that would solve part A of find the work done by the force going to y1 over y2, from y1 to y2, right? Because we could figure out that, okay, although they don't give us the exact mass, but we can at least put into terms like, okay, we know that it'll be greater than 0, so we know the kinetic energy will be positive than 0 at least. Then we can go on to B. B says find the velocity at v prime, v equation, v parentheses y equals 6m, right? And basically saying velocity final, right? And we use the same equation we used originally to find a difference, right? So we go 1/2 v f squared minus 1/2 and v I squared equals to w, right? Or in this case, it'll be, kinetic energy, work, right? W being work. But then we can cancel these out, right? Because we know what we're really looking for is mg4, right? And we can cross out some things from our equation, right? For example, like we have this here, and we could also cross out the velocity initial, because we know from originally we wrote down that velocity initial was 0, right? And basically we can dumb down this whole entire formula, right, to 1/2 velocity final squared equals to 2g 4. And we got the 2 because we moved it over. Okay? And then after we work it out, we square root it, right? We know 1/2 is just square rooting it. We square root this, and this becomes this is a g square rooted afterwards, and then we're left with eventually, after we continue doing algebra, we're going to be left with equals to square root of 80, right? And that'll essentially be our thing, which will be velocity final is equal to 9 meters per second, right? After we do the square root and all that. Okay? So eventually that's what it's going to be. Move the drawing. So that's for B. We found out that B was 9 meters per second. Now if we continue on to C, right, we're talking about generalize the equation for any y differential. So when we look at C here, we can say that, okay, it'll be W equals to force times dy, which eventually just turns into mgy, which then turns into 1/2 mv final squared, right? Which is the kinetic energy, right? Or the work that we were originally talking about, right? And then we're going to be left with, if we continue going, we'll rewrite this now. We'll have 2g dy equals to velocity squared, right? Because remember, we're looking for that force displacement, right? Which we know force is just equal to mg, right? And essentially, we're going to be left with this being one of our final answers here. Okay? And if you want me to write it off for you, I could. It's like force is equal to mg equal to y, because this is just force displacement, Oh, this is just force displacement. Okay, nice. So now we'll go on to D after we just answered that one. We did A, B, and C now. Now as we go on to D, it is we're looking for find the potential energy associated to the force, which is from the original problem that we talked about earlier, where F is equal to negative mgj. So we look here, and we can do this. V equals to mgh, V being potential energy this time, right? That's what we're essentially looking at. Potential energy, right? And this turns into m times g times displacement of y, right? And then this turns into m times g times y, 4, sorry. And then equals to, eventually, this is a g, mg, 4mg. 4mg is like what we're looking at here. So now we have 4mg, we broke it all the way down to there. And then we can go down to saying, okay, remember work displacement is just velocity final minus velocity initial. And then work is just mg displacement of y. So potential energy is the same as equal to mg4 that we talked about earlier. Okay? So yeah, work equals mg displacement of y, so potential is the same as mg4. Okay? So that's for D. Now let's go into the final part of this problem, which is establish the principle of conservation of mechanical energy. And the mechanical energy equation, right, is going to be VI plus KI equals VF plus KF, right? And we could break this down into mgh plus 1/2 the initial squared equaling, right? Final being 0, or the initial, I'm sorry, being 0. No, this is the final, I'm sorry. Over 1/2 mf, mvf squared. Okay? So, yeah. Then we could come here and we could cancel this initial part out. Remember this, because this is a 0 we talked about earlier. So then we're left with, I'm going to rewrite it now so it's easier to see for everybody, that it will be mgh equals to 1/2 mvf squared, right? So then as we get to here, h, by the way, is the height, but it's also displacement, right? So don't forget this, which is just displacement. Then we will break this down into 4mg is equal to 4, because we talked about this earlier, remember? So yeah, this will be the final answer for us, basically. We'll talk about the conservative energy equation. And we originally started with Vi plus Ki equals to Vf plus Kf. Okay? And remember how we got these, because we just plugged in from earlier that we got. So we're left with 4mg equals to 4mg. Okay, we answered these questions. So it's just a recap. For A, we said that Ke is greater than 0, so we know that at least. We know that the velocity final would be about 9 meters per second. We also said that Vi is 0, that we established that. And continuing on, we found out the force displacement of Y is just mg in this scenario. And we just discussed the conservation of energy equation. Okay, perfect.